Okay, I'm going to briefly explain page 13, question 13 table for the homework. If you haven't done it yet, you should. So the first thing to do is to complete the data table to the right. Then, using the completed table, you're going to plot the velocity time graph on the axes below, and then perform some mathematical analysis. And so the first column that we are responsible for filling out is delta t. Delta, we remember from unit 1, means change in. So it's going to be the change in time for these two previous rows. And so any row that's grayed out, we're not going to fill in. And so you can see that this box is in between two other non-grayed boxes, 0 and 1. So the change in time is 1 minus 0, which is equal to 1. Next, we have to fill out our change in position between these two boxes, 5 minus 0, which is 5 centimeters. So now T mid. Mid means midpoint. And so we're going to figure out what's the middle value between 0 and 1. That would be 0.5. And then to calculate the average velocity, we're going to use velocity average is change in position divided by change in time. So 5 divided by 1, which is 5 centimeters for every second. Let's do another row. So now we're doing change in time between 1 and 2. That is also 1 second. And let me just realign this. Yeah. And so then our change in position, I can't figure out how to do that, is 20 minus 5, or 15. The heck? Let me pause the video to figure out this formatting issue. If you have this problem on your table, you have to click on the table and hit format options, text fitting. And then in the text fitting, let me show you text fitting. You want your left indentation to be 0. Okay, so 20 minus 5 gives us a change in position of 15 centimeters. Now the middle value between 2 and 1 is 1.5. And our average velocity is change in position over change in time, which would be 15. All right, let's do one more. So now we're going between time 2 and 3, so our change in time is still 1. Our change in position is 45 minus 20, 25. Our middle value is 2.5. And our average velocity is 25 divided by 1, change in position over change in time, 25. So now you're going to take these two columns here and these two columns, and we are going to use them to graph a velocity time graph. And that is the next step. So plot a velocity versus time graph on the axes below. So we're going to have T mid and V average as our as what we're plotting. And so let's go ahead and plot these 3 points. We've got 0.5, comma 5. And so if you have your physical version of the workbook, this might be a little bit easier, but it's totally up to you. So we start at 0, and I'm going to say like every 4 is 1 second. So 1, 2, 3, 4. That's where 2 should be. 1, 2, 3, 4. That's where 3 would be. Etc. etc. And this is for T mid. And then V average, we go from 5 to probably some pretty big numbers. So I don't know, it might make it go up by 10 every 2. So this would be 10. And 20. Okay, let's plot our points. So we have 0.55 right there. 1.515. So 1.515. And then we've got 2.525. And so we've started to get a velocity time graph. And that is what you should continue to do. And then after you've got your velocity time graph, yield a mathematical model that describes a relationship between velocity and time. So you're going to calculate the equation of the line for this graph.